All right, so we're back.
Cool. Now I can show the Roman semantics, which is almost the same, but it's a little more complicated to get the correct digits.
Yeah.
And this is like a really naive implementation. I'm allowing something that is not usually allowed, like more than three the same digits and something like that. I'm not sure how to exactly construct Roman numerals and what's the correct
Yeah.
way.
Yeah, neither were the Arabs. That's why they gave us better ones.
I found out that there is a different ways and okay. But yeah, I'm creating a list with all the digits and how they are represented as an integer and how they are represented as a string.
Mm-hmm.
And I'm just picking the correct one.
What is that operator that sounds really surprised and confused?
It's finding a value from this list.
Oh, okay.
Not from a list, from a map. This is a map, not a list.
Yeah. It's like you look for the key and give the value associated with the key.
Yeah, exactly.
Yeah.
And it returns maybe. So I'm just using just.
Yeah, and maybe it's like an option in ML.
Yeah, exactly.
Yeah.
Option.
Yeah.
Okay, yeah, cool.
So it's almost the same as with Arabic numerals, but I'm not using index. I'm using the map.
Cool.
But everything else.
Yeah. Okay. And then, okay. So now you have eval rn and show rn.
Yeah.
So how does eval rn work?
It's going recursively, but from the back, from the reverse, and just subtracting or adding each digit.
Okay, yeah. So you're doing a fold. The starting value is a pair of zeros, and you're folding over this list of Roman numeral characters backwards.
Exactly.
And then f is your folding function, so that's what's down below here, I guess, right?
Yep. And in each step, the first argument in this tuple is accumulator, which this is the resulting value that I want.
Mm-hmm.
And I must have this last value from previous step because I must compare it. Is it smaller than the existing one? And if it is smaller, I must subtract from the.
Wow! You actually did implement that. This is when you put like I before v, and it gives you 4 or something.
Yeah.
Okay,
that's cool.
I was thinking that this will be like more complicated, but no, it's not.
Okay, and otherwise you just add it on, right? Most of the time you're just summing it, except in that special case where v is less.
Yeah. And then there is a bunch of different other rules, as I said, but I didn't bother with this.
Yeah.
So now we have Arabic numerals. We can use it separately. This is like our implementation of the Arabic numeral language. And now I can show you for addition. This is like a combination of these two, not combination of these two languages, but combination of addition language with some other language that gives you digits. And this other language it's really not only one, but two languages. So the parser is again completely separated from the initial, from the representation, from the concrete data type. It only depends on the type class, on the final representation. And this is why this type is more complicated. This is like a type alias, which combines all of these languages in one. And what is the definition of a parser is parsing all the Arabic digits, parsing all the Roman digits, and this can also be with in the brackets. And parser is any of these three things separated here with the plus. So
wait, I'm mostly with you, but I don't understand line 28.
28.
Yeah, the p addition.
Oh, yeah. So this is like the recursion part.
I didn't realize there was another parser called p addition below.
This is the definition for p addition. Okay. This is like the whole parser, but the whole parser can be inside the brackets.
Okay.
And this is like I found out that this is like an easy way to define this recursion.
Oh.
And so this recursive definition is defined in a way that you can separate it with the spaces, this P4, and P4 is everything you can parse, and this is separated with character plus, which is parsed in between. Mm-hmm. And of course, the binary operation is for combining.
Yeah, right. So last time you used this like chain L1, you didn't have to parse a plus sign. You just had the operator on the right side.
Yeah, but you can on this side you can specify any parser that you want. I mean any parser that is a parser of a function, right? Because you will have these two values.
Right.
But you can put any parser in before. So to combine these P4s together, you must have plus in between.
Yeah.
And that's it. In a sense, I see this in a way that you want to combine something on the left with something on the right. So you can easily do whatever you want. You know, you can say, okay, this is like my separator for combining, and this looks very nice because this is like a combining operation of monolith. So it's exactly what monolith is. Yeah. I mean, like a semi-group for combining. And I also fixed the problem where if you before I have this error that I also must fix this in Roland. When you not specify the whole string, and you can specify some error after in the middle of the string, but the parser will parse the first part and just forget the other part. But the other part is an error.
Yeah, I couldn't solve that when I was trying to do Roxy in Haskell too. It looks like you just had to import it from the right spot.
Yeah, I think that I'm not completely sure if this is like completely correct, but I think it is because this is not part of the addition parser. This is part of the final parser, which says, okay, I parse this, and after that is end of file, end of string. So now it's working as expected. You know, you will not stop on the error, just forget everything else. If you stop on the error, you must stop on the end of the string, not in the middle.
Yeah. That's good to know. Yeah, very nice.
But I like this because now addition parser is completely separated. It can be in different project and everything will work.
Yeah, really nice.
That was my goal.
So what's this run unsafe thing? It just takes a...
I'm calling unsafe because in a case of left of error, I will just throw error.
Oh yeah.
This is why it's unsafe. But it's nice because I don't have a result inside the either. I have result directly. So It's I'm using this run safe when I use when I'm developing in a REPL. This is like
yeah. Okay, I see. Okay.
Because you know what? Because if you use toString or something to convert to string, you don't have you get breaks as escape with the \n but you want to real string.
Oh, yeah, and you want actually to see new lines. Oh, that's interesting.
Yeah.
Yeah, nice. Okay, well, that's really great. Yeah, I was hoping you were going to show us.
So new run current REPL map. Oh no, REPL. Okay. Oh, I didn't show you addition semantics. Okay.
So yeah, that's right.
Using string and the evaluation. This is like a show, and this is eval. So with this 4, you see this is like a result. I mean, this is like an integer representation, and this is a Roman representation. And now I can say plus 10. And now you see two different representation. You can see, okay, this is like an integer, but I want to know like exact how it was.
That's awesome.
That's of course, you can put parentheses whatever you want.
Wow.
Oh, that's awesome.
That is super cool. Cool. I want to see it parse like CIV or CIX or something. Nice.
But you can also do something like that.
Oh, I see what you're saying.
Which I'm not sure that is correct. You know?
Oh, yeah. I see. Okay.
But implementing these rules is not so.
Oh yeah, I would you shouldn't be able to put so many I's because they should have to fold up into V's or X's or something.
Yeah. And I mean, there is some kind of rule. If this is not correct, so
yeah,
this is the error. And I'm thinking this should be syntax erasure here.
Mm-hmm.
Not here in semantics. This should be like a syntax error when you do some kind of stuff like that. And this is like very important. I'm not sure who said that. So you have this definition in type class. Well, for Arabic and Roman numerals, for Roman numerals. So you have this definition for digits. And not all combinations are correct. So in this definition of a language, you don't say what is the correct or not, but implementation in some concrete structure will constrain your language to valid terms. This is like the point, and now this totally makes sense for me. Before I couldn't grasp this completely, but now this totally makes sense. You know, this is like a definition of all the possible ways for you to create your terms in your language. But when you interpret this in some concrete structure, you will eliminate some structural differences, and you will say like what is the correct, what are the correct terms.
Yeah. Yeah.
So
nice.
in that sense, here I can say, okay, if you have something that are in this kind of structure, for example, the 3 M's, this is not valid, and you just throw error or something.
Yeah. Right. Hey, Tomislav, I feel like you should tell Jake about this. I think he would be interested in that. Because he worked on this assignment too, right?
Yeah. Oh, I will. That's it.
Yeah.
I would like to hear his opinion. Yeah.
Yeah, and he'll appreciate it a ton too because he's been in that trench. You know, he's fought that battle.
Yeah. Yeah.
Nice.
I will just show you the rolling part.
Yeah.
I will be quick.
So give us the release notes first. What are the new things you've achieved or that you're excited about in this one?
I can show you the previous and the current version.
Okay, cool.
So before I had this two different definitions for process and for names, and I was not completely clear. Sorry about this relationship, and so I only have these variables inside the concrete structure because I was thinking like that, but in new implementation I can separate these things in a better way. So I have these two definitions which are very similar, but I have separated definitions on this final representation. I have variables and like a name variables or process variables.
Okay.
And I have definition from ground terms also, not only in the initial representation in concrete syntax, but I have it in this abstract.
Okay, help us parse the Haskell, or at least help me parse the Haskell on those last couple lines. So you're making a class called ground name semantics, and it's parametric in some concrete type n, right?
Yeah.
And then, yeah. So it has 4 functions, and they all return. That's where I get pretty confused.
Yeah, and this is the change really that I made. Okay. So what is the difference here? N is N here is a type. Like when you will implement this class, this will be normal type. And what I mean normal, I mean it will not be parameterized in another type.
Okay.
And in this case, this n is not a type. This n is a type constructor. It will create a type when you give it this one argument.
Okay. And I see you've done that up on line 7. Or oh no, that's where you created that big N though, right? What is that? Just makes N a thing.
This is like a type without constructor. This is
it doesn't have any constructors. Oh,
no. Okay. This is sorry. This is like 2 separated types. But
yeah, right. I got you.
They are just
types, but neither one of them has any constructors, right?
No, you cannot construct an instance of this type.
Okay. So here's just a question. Why didn't you make it a single type that had 2 different constructors?
Because I'm not using these types at all on the value level. I'm using it only on the type level. They're just like a tags.
Yeah, I see.
Like a labels. So I want to have 2 different way of creating this final type, right? So I want to have this. Yeah.
Is it almost like, so I think I have a really good grasp of like creating a data type that has a couple different like constructors or tags that you can use. And it feels like you've done something like that, almost like one level more abstract, where this like little lowercase n, it almost is like an abstract type that has 2 different constructors depending on whether the next type is the big N or the big P.
Yeah. And I'm using again something from Oleg's work.
Yeah.
He's explaining this exactly as you you just want to have two different things to differentiate, but you don't want to have like some type that you will use on the value level. You will not use it to put any values inside. You just want to because this is full abstract. So you just want to say, I have these two different things, and when I will implement this, then I will decide what will that be.
Yeah. Okay.
And this is why I'm not using type functions at all in this implementation, because I'm using type functions in the implementation side.
Yeah.
I didn't get this the first time, and this is why I was using this kind of thing. And this is because this is why I couldn't make this work with the parser.
Yeah. Yeah.
So yeah, this N and P are just type level labels that I'm using as a parameter to this P. And this P is the only thing we know about P and N are that they are type constructors, and that's it. They're accepting type, and that's it.
Oh, they're just type constructors, and we know, and I can see from the code that you're only going to ever give them the types P or N, the capital P or N.
Yep. And now I can use this definition with the parser. Not some concrete type. I will use only this with the parser.
You'll use only which ones now?
Only this. Only. Sorry. No. This is 3 and 3. I'm using only these definitions in the parser, not the concrete data types.
Oh,
so
okay.
I shown you only type classes, and now I'm showing you the parser, and the parser only depends on the final representation.
Okay.
If you remember, I said in my first example, I done this, but it was not working. If you remember, I was using this different extensions, and it's type checked, but it's not working in the
right. Yeah. This is seeming a little bit familiar. So now, if I'm understanding right now, in your Rolang 5, you have it set up so that the parser can, so that it's all like final encoding / shallow encoding straight from the parser, is what you're saying. Right?
Yeah, and this is exactly what is the correct way, right?
Okay.
Because you don't want to depend, that parser depends on some concrete type. You want to just say, parse this and, call these functions. And I will decide later what is the correct implementation or implementations.
Yeah, well, right. That's the thing that's so nice about the shallow encoding, right? Is that you can have a lot of different implementations over the same parser.
Yeah.
Or even over the same data, I guess. Because yeah, go ahead.
Or the same definitions, over the same abstract definitions, and this is really corresponds to parser, because a parser can parse whatever you want, even if this is not correct term in your language. He will parse it. If
the characters line up in the right way.
Yeah.
Yeah, so I was reading one of the papers that you shared about deep versus shallow encoding, and the thing that really made it start to make sense to me was that I feel like I still understand the deep encoding better, but at the time my head was so stuck in there. And basically, like, when you have, wait, how did that go? I remember they were talking about, like, they might want to do multiple different things with like with a process, for example. And so it might be that you wanted to like evaluate that thing and see how the program ran, or you might have wanted to pretty print it, or you might have wanted to like count how many like leaf nodes there were going to be in your tree or something. And
exactly.
Something like in the deep encoding, each one of those is a different function that will process the tree, the deep tree that you give it. Whereas in the shallow encoding, it's like different implementations of the class that you've called, what was it? Process semantics or something semantics?
Yeah, semantics. Yeah, process semantics. And yeah, exactly. You're totally correct.
Yeah, I'm starting to like kind of wrap my head around these ideas. I really appreciate how much I've gotten to see like the thought pattern develop as you work through them. It's a lot more helpful than just reading the paper.
And you get it correctly. The final representation is just some kind of function, but you don't want to say you don't want to mention the concrete type. You're just saying this is function when you call it. This is a function when you implement it for your concrete data type.
Yeah.
Then you will apply some kind of additional rules to your implementation language.
Yeah.
And yeah, I didn't show you for numerals semantics, and this is my concrete data type. I must show you this because this is like the important thing.
Yeah. So you have a data type called addition, which is parametric in something called A. Wait, why is that a data? That looks more like a class than a data type.
Oh, this is GADTs. Generalized algebraic data type. It's very similar. I think I could use like a regular abstract data type, but
okay.
I like the definition of GADTs.
Yeah. So what does it mean though? It is a data like are add and gen constructors in your data type addition, or how does that work?
Oh, let me rewrite it in normal way. Maybe this will be helpful. I can do it quickly.
Yeah, cool.
But I'm not do the whole thing. I will just add A and A.
Oh.
I can do the whole thing. And addition, like this, and gen. So this is the same thing.
Oh, it's either like just a number or an addition of two numbers, or an addition of many numbers. Wait, why is it a multi-set? Oh yeah, duh, because the order doesn't matter. Yeah.
Yeah, and this gen is generator. If you remember for Greg's lecture, when he's saying you have n and n parameterized in G. And this defines a new language with 0, with G, and with add M of G. And he was using add as a plus because this is abstract plus, right? And this is exactly this definition, right? Or this definition. I'm seeing this.
Where's the 0 part in your definition?
Good question.
That is, yeah. Okay. Thanks.
Let me show you my process now. This is initial encoding. This is my concrete data type for process. There is no 0.
Yeah.
I found out that here I don't need 0 because 0 is an empty multiset. And this totally makes
Oh,
sense.
yeah.
If you remember, Greg was explaining that this one is a empty multiset, or I'm not sure.
So
But I found that, yeah.
You're using multisets as your pars, and so when you par zero things together, that's obviously just the stopped process.
Yeah.
That's a pretty nice idea.
But I think that in Scala code of rolling on Arche, they also have like a only par to represent rolling term.
Yeah, to represent every process, right? Their data structure is called par. Yeah.
In a sense, this is this and for addition. It's a multiset with other the same things, which is totally the same as a process.
Yeah. Oh wow.
It's part of a multiset of processes.
That's right. So you
addition.
Yeah. So you can express like it seems like a natural question to say like, how do you express all of the integers 0 through 9? And for the most part, the answer is, well, that's a gem, that's line 13. But 0 is different. 0 is an addition of no terms.
Yep.
Yeah. Okay, I gotcha. That's really cool.
So I'm totally happy that this is like very similar to Greg's explanation. You know,
yeah.
Now I really have this gem, this gem G. You know, before I didn't have this, and I was not satisfied. You know?
Yeah. It's always especially satisfying to solve a problem a year later after it's then relegated to the unfinished pile. Yeah, that's cool. Good.
So yeah, and there is no much of the change in the other part. So now I want to apply the same thing in the initial representation of the roller.
Yeah.
I want to have a parameter here, and not depend directly on the process. This is the I want to have the process that also have a parameter, and yeah.
Okay. So Tomislav, I don't know if you're open to nudgings, but I'm extremely interested in seeing how you're going to do com reductions in Haskell, because it was not easy. I got them to like barely work and I didn't feel good about it. So I would really love to see the like correct, clean way to do it.
Yeah. You probably seen that I like I'm circling about the comms, and I'm thinking, you know, how to do it, and but I'm still, you know, not completely sure. Now I'm thinking I want to use effects and do it with effects, and this is my last thought.
Yeah, cool.
But yeah. Now I'm happy with this. I can go further. Yeah, this is it.
Nice. Good.
Yeah, I think that this everything I want to show you.
Isaac, were you going to show us some K-framework space-time calculus?
Yeah, I could show some of that stuff real quick. I don't have too much more time. I got to get out of here pretty soon. But yeah, I can show some of that stuff if you want.
Just want to mention that here's the implementation of this semantics, right? And now it's separated with each type class. So in a case of a mill, I'm just creating an empty multiset.
Oh yeah.
Oh yeah. Okay, I see. Yeah, nice.
Okay, thanks for listening.
Cool.
Yeah. Oh yeah, that was great. I'm happy to see it.
Yeah. So in this space-time calculus, right? The only names that he has are like quoted, he does this thing where he like pairs processes with contexts. So these are the only names that he has, but I also introduce name variables because otherwise it's just like horrible to actually like type out all of this stuff. But either way, then and I also introduced like some normal ground terms in other than just like the stopped process. So then the process constructors are, they have this U with a name inside, and this is for like a location update. And I'll show you the semantics for that. And then just like, usual receive, send, eval. And then there's also this com catalyst business, which basically is just carrying a context for the com to happen in, and then also a par. And I'm messing around with some different attributes. These are like built-in things in K framework, but I'm not sure they actually do exactly what I want. So I'm kind of just playing around with them. And I'm pretty sure this is for like, associative operation, and this is for like commutative. But like I said, I don't know if it actually does what I want it to do yet. Yeah.
Okay, so let me make sure I'm with you so far. So there's two kinds of things that you can oh no, there's instead of quoting processes, you're quoting pairs now of contexts and processes.
Yeah, that's right.
Processes you've shown, it's largely similar to before with a couple new terms.
Yeah, we have these location update things and these com catalyst things.
Yeah, and then so is context defined somewhere? Oh, that's what we're about to get to, maybe.
Yeah, exactly. And the context is like kind of what you would expect. It's just like process context. This is the com catalyst.
Can you? Is it allowed to use it to create a name or use a name without context, or now it's everything must be with the context?
Yeah. So the way that it is defined in the calculus, it's just every name has, it's a process with a context. But just like in the regular row calculus, every name is a quoted process. We can still introduce our own notion of names, and everything will still work out fine. Because basically the names are just like locations anyways, so it doesn't matter all that much as far as I can tell. But I haven't experimented too much with it yet. There was one weird thing that I had to do is I had to add a different notion of substitution so I could get the right rules for the reduction with a com catalyst, and I'll show you how that kind of comes into play in a second. And let's see. Yeah, and then I was just kind of messing around with different ways of writing down these terms. But the important thing is the context. So basically the contexts are like, well, you can have, just a whole essentially is just this placeholder. Whole is already a defined term in K framework, so I had to use something else. But then you can have.
What does it mean in K?
What's that?
What does it mean in K?
You can define context in K as well, and it means exactly the same thing. But I mean, they type it out. I think it's like that or something. But either way, it means essentially the same thing.
Cool.
And the whole in the context is really like a zero, right?
Yeah, it's like a placeholder essentially. It's just something that to make that context into a concrete process, we'd have to substitute a process or a name or something in there.
Yeah, like I almost feel like it's the explicit substitution thing that I was complaining about not having in Rolang, where I wanted to just like drop part of a process into this other one that I already knew, and the whole is the place where you drop. It's almost like a variable that you can sub in for, right?
Yeah, exactly. Yeah, and it has no other meaning other than it's like I'm waiting for something to be substituted in here.
Yeah.
So so we just have like a regular like whole, like you can just put a process there, and then it's exactly what you would expect.
So Isaac, Like in terms of writing an evaluator or interpreter or something, it would be the case that like if you ever found yourself trying to execute a whole, that means something went wrong earlier, right? Like something failed to substitute, or like you never should directly execute one of them.
Yeah, and it won't happen here because it always needs to parse as a process, and these things as they stand are not processes.
Oh yeah, okay.
Yeah. Yeah, so we have, just a whole, we have like a continuation context basically. So like, whatever, receive that you have that prefixes that continuation. And I've just kind of left it so that, if I wanted to do like persistent send or peak or something, I could, but I didn't implement any of that stuff yet. And then we have just like a send context, like we know the name, but we're not sure what the process is yet. We're kind of still waiting for that. And like a par context. And then...
this is confusing for me. I remember when Greg was explaining. The par is process and the context.
Yeah, right.
Yeah, my first question. Really. Are we ever going to have reduction in with the context?
What do you mean reduction with the context?
I mean, are the contexts in that sense similar to processes, that we have some kind of rules of structural equivalence reduction, or the context is just something that you put as a catalyst to reduction? Because why I'm asking, because a context also have a receive and send, but you will never match, right? You're never matching the receive and send in context. You don't have this kind of thing, right?
So I'm not 100% sure. I think we could kind of build a notion of structural equivalence for a context that just literally comes from the structural equivalence for processes, and probably name equivalence as well, because we have this send context, and I guess and the receive context. But
Tomislav, is part of the thing you're getting at, like, why the heck isn't there context par context?
Yeah, this also, yeah.
I remember at some point Greg was talking about like single hold context versus multi-hold context, and he kept saying like, yeah, it's totally possible to do the multi-hold ones, but like we better build up some intuition with this simpler one first or something. Yeah. And so like if you put context par context here, that would allow you to take some single hold contexts and turn them into multi-hold contexts.
Mm-hmm. Yeah, so these are just the single hold contexts.
And then there's above, back in the more normal Rolang looking stuff, you did have the par of proc par proc. So we've still got that as a regular old process that we can use as part of our definition for com events, right?
Yeah, exactly. Yeah. Yeah, and so let's. I mean, that's it for the syntax and everything, and so the configuration is like literally copy and pasted from the rocalc stuff that I've been doing. So we still have some notion of like different threads of activity, and this is just corresponding to like pars and the processes that are running in parallel. And then the tuple space cell, which is again just like several sends and several receive cells. And the two things that have been added are the cell for catalysts, which is basically just like when I see something like a com catalyst, part into an expression, then that context that's there will go into this catalyst cell. And basically all that's going to happen is like for a com event to happen, I'll need some context in this catalyst cell that I can, then consume in the com event. And then a similar thing for location. So if I ever see something like that constructor that you named constructor, the location update, I'll just put that name here, and then basically if there's ever, so how does it go with the location updates? So with the location updates, where did I do that?
Okay, can you explain the location updates, because I'm
yeah,
not,
I also don't really understand the semantics of the calculus.
Context somehow
Here.
looks familiar, but update is totally.
Yeah. So the location update, from my understanding, was just a way to somehow combine, like, so if you have one of these names, right, they have a process and a context associated with them. But if you're trying to drop the quote on this thing, well, you can't just do that in this calculus that we're talking about now. You could in the regular row calculus, because it was just a process underlying that, and that was fine. We had a notion for that. But we don't have a notion for this context with this process, just paired together essentially. So my understanding was so that if we ever see something like dropping a quoted, dropping a name now, what we're going to do is we need a way to make this context available again for, another comma event to happen. And so what we're going to do is basically take one of these names that we've designated for a location update and just make it into a channel that we send the process on, and then at the same time make that context available again for a comma event. So this is kind of the rule here, maybe in a less weird way.
Yeah, this is starting to make sense. So let's the comment on 138 is, you're saying, is more of a like equation-y way than
this would be like when you're looking at the syntax for the calculus, like this is the rule for a location update, right? So you have that certain constructor, right, just designating this name as like a potential location to update, and then like I'm saying, the only point of that is so that we don't just get stuck with all of these like dropped names that now do nothing, because this literally can't interact with anything else. So the way that it interacts is with one of these location updates, and basically what it's going to do is take this context out, make it available as a catalyst again, and then take this process and then just update that name by putting the process on that name.
You're saying by like doing an actual tuple space send.
Yeah.
X. But X is itself one of these at context comma process things.
Yeah, right. But we've kind of skirted the issue of having this dropped name.
Yeah, okay. So when I try to, so let me see if I understand this correctly.
Yeah.
When I try to drop a name, like all by itself, if that's the only thing in the process, that doesn't reduce. We're stuck.
Yeah, right.
But if I try to drop a name in par with one of these location updates, and there's no relationship required between that update and that drop, like any two of them can work together.
Yep.
Then that just rewrites exactly the way you've said it. It gives us this other new term, which is a com catalyst, which takes the context out of the name that you dropped.
Yep.
And then it also just turns into this like send this like X bang P, I guess, right?
Yeah, right.
Okay, I think I get those semantics. I'm not totally clear yet what that is going to get us, but sounds like a cool calculus.
Yeah, I'm gonna turn my video.
How you get the send from X?
Hey, hold on 1 second. I gotta grab my charger. My battery's about to die.
Josh, you said that this X send, right? And I'm wondering where this send came from. There is an update, a location update for X, and they're in par with this second expression, context the proc, and now we have a send on X, and we are sending P.
I mean, I guess, Tomislav, what I was saying is like, if you're just telling me that comment on 138 is a reduction rule, I think I get it, and I think I could do some like example reductions. I don't yet necessarily understand like what new cool features or expressibility this is going to gain us.
Oh, you're saying this is like a reduction rule.
Yeah.
Is that right, Isaac?
Yeah. They he called it. Do I have the? I don't have the slides up, but that's all right. Yeah, he just called it a location update, just like the com rule was a reduction rule. Now this location update is also a reduction rule.
Oh, okay.
Okay, yeah, cool. That makes sense.
So
Yeah,
you just put this name, but this X name can also be context with the process, right?
Yeah, and in the proper calculus, like not in my implementation, that's all it can be.
Oh, okay.
Yeah.
Okay.
Yeah, so let's see. Yeah, just going through the semantics of each thing. So the pars do exactly the same thing, just generate a thread for each thing in the par, and then just put each process in its own thread. The com catalyst does, exactly what I was saying. It does, like, when it's the only thing in the thread, then we're just going to throw it into that context cell. Same with
hold on, say that part again.
Yeah,
when
so
catalyst is the only, so like when there's someone just pars in a com catalyst term, it's just like sitting there in the process.
So the way that I'm thinking about it is basically it's going to go through processing, all of these top level pars. That's like the first thing that it does is it takes all of the pars on the top level and generates a thread that contains each one of those individual processes. That's kind of like the first step in like populating the configuration.
Totally.
And so the only way to see one of these com catalysts is, had it been parred in originally. And so it'll just be sitting in one of these thread cells. And so if I find one of those in the thread cell, then I'm just going to generate this context cell that contains that context.
So is that still, it's not a thread anymore, right? A context cell is a totally different thing, you're saying.
Yeah, it's a different thing. Yeah, so it's just, it lives down here basically.
So it's just another part of the state machine that we didn't have before. We're keeping track of a bunch of catalysts that are laying around.
Yeah, right. Yeah, and I mean, like, this is not, totally essential or anything like that. Like, I could look in, thread cells for these com catalysts, or I could, put them all in this context cell, and then I'll know that they're in the context cell. I mean, it's, right, a design choice, I guess.
Yeah.
But it kind of makes, well, I guess, it could go either way, really. And then same thing with the location updates, right? Like, anytime I see one of these location update things, I just put that location into the location cell. And, so then it's like, if I ever see one of those like prop names sitting around, then it can kind of partner up with this location and do one of these location update reductions, which is what's defined here essentially.
It almost feels like it's just an extension of the tuple space. Like, instead of just keeping around and appropriately filing your sends and receives, you're now doing the same thing with these updates and these catalysts.
Yeah, right, exactly.
I wanted to ask you the same thing as Josh. So we now need to have not only tuple space with names and these two maps. We need to store this com catalyst and also the location update.
Yeah.
And when we want to make a reduction, we must search for these things, right?
Yeah.
We must say, okay, we have two names that are the same, right?
Mm-hmm.
As a first step, right? Like a normal reduction. Two names are the same, but we cannot make reduction immediately, right? We must first search for com catalyst, and after that, if we find it, we can say, okay, we will make a reduction. Yeah. And for update location, we must find out this send with the catalyst and then make. Is this correct? Yeah,
exactly. So the way that I was thinking about the tuple space originally is like So for me, kind of like the receives or the listens within the receive are kind of like the native things to the tuple space. And so like we're always asking questions about how does the COM work in terms of like the receive or the listens, like searching for sends that match with them. But now it's not only do they need to find, you know, a send that matches with them, they also need to find one of these COM catalysts to make the COM event happen.
Okay. Now it's much more clear. Thanks.
Okay, cool. Absolutely. Yeah. And so, I mean, and that's essentially all that this is saying, right? It's just capturing, if we have one of these dropped names, you know, a name that has one of these contexts and processes, and we have some location to update, then we can go ahead and do that location update rule, which is basically just, you know, deleting this thing from the computation cell, deleting this name from the location cell, and then also generating a new thread that contains that COM catalyst and that send that it was supposed to generate.
Oh, now this makes sense, which Josh said that this is like another reduction rule. And
yeah, exactly.
Yeah. Right? Mm-hmm. You have these two things and you pair it together, and now you have a COM, catalyst, and the send.
Yep.
Oh, okay.
Yeah.
So Isaac, we still have something that resembles a normal like send and receive on the same channel reduces rule, right? Like more like the traditional COM rule.
Yes, with the involvement of one of these COM catalysts.
Yeah,
so, right. Yeah, so like send and receive stuff is literally identical to what it was before, basically just storing all of the information associated with each in a respective send or receive cell. There's not a whole lot going on there.
Okay. Is it correct to say that currently this is the same as empty context?
Well, so the usual COM rule now is one of the how do I want to say it, is one of the reduction rules here with that context that is just a whole, if that's what you're asking.
Okay. Yeah.
Okay.
Yeah. And I have a question with now this is not implemented in the current version, right, of Roland?
These different contexts?
Yeah.
Yeah, I don't think so. I would be very surprised if it was.
And
yeah, did you say Rolang?
Yeah, Rolang.
Yeah, this is not in Rolang. That's right.
Yeah.
And this will be implemented, right?
I don't know what the plan is, honestly.
Definitely not anytime soon. This isn't even in that spec that we were looking at this morning from 2 years ago.
Oh,
right.
Okay. And what do you think? Is this part of the final syntax? Or I'm thinking.
I think you're asking us to predict the future.
Yeah.
But I'm more thinking that is this context something that is part of the language, or is something that is part of the interpreter behind?
Oh yeah. Oh, you're okay. So Tomislav, you're saying like if someone makes a Rolang-like language that wraps this calculus instead of the row calculus that we've been talking about, like does the Strolang programmer, space-time Rolang programmer, have to like type in as part of what they care about, like contexts and location updates and stuff?
Yeah. Exactly.
Yeah, I think it would be part of the syntax, or at least that's the way I'm capturing it, right? But maybe it doesn't have to be. But I don't know how you assign. Yeah, I mean there might be some sort of like ad hoc thing that you can put on top of Rolang to give it these features, but not have people talking about names like a quoted context with a process. Maybe it's just like, I don't know, you supplied a context in a process and then you have your name or something. I'm not really sure.
Okay.
It seems like this is probably a more expressive language, and so like there would be a way to take the row calc we know and give it some like sensible defaults for context and updates and stuff, and like still be able to. I guess I'm saying trying to like imagine a way to encode the regular old row calc into this calculus.
Right.
Maybe something would exist.
Yeah, I mean, and the encoding of the regular row calc into this one would be like basically always using that just single hole as your context.
Oh yeah, that's right. Yeah.
Yeah, but we don't have any notion of location update, so I'm not really sure how that fits into the picture. But
yeah,
either way, I mean, so the com rule now, I guess you could call it, right? Because we had the location rule was one reduction, and now we have this new com rule is another reduction. But it's essentially the same as the old com rule, except now you need the presence of one of these com catalysts to make the com happen. And essentially the only thing that's different is, so where we would have just placed, quoted Q into, substitute it for this variable Y that we're calling whatever we receive on channel X. Now we just quote that process in the context, essentially.
Oh, wow. That is not what I was expecting. I thought we were going to do like take Q and fill it into the hole in C and then sub that in for Y.
Kind of like this.
Yeah.
I mean, that's more or less the interpretation of that, like quoted thing that was just there.
Yeah.
Except now, you also so there's also a semantic substitution for this calculus, which is basically like it's on this line. I mean, it's basically like if we were to do this substitution and say like this process is just like an evaluated Y, right? Like it's just star Y. That's it. So if I were to do this with star Y being the process, then it would be exactly what you said. This would turn into just this process filling in the hole that is in this context.
Really? Oh, based on that rule that you had up above about how we drop those?
Well, and it's right here specifically. So like, so this is where the substitution rule changes. So I can't just do direct substitution anymore. So now I built this new function for substitution, which is basically like if these, if it's not this very specific situation for the semantic substitution, well, then it's just the ordinary one, which is basically what this second part of the rule is saying is like, I have some process, I have a name that I'm trying to substitute for another name. If it's not this special situation, then it's just the regular substitution for, A for B. But if it's this, evaluation first, like a name being evaluated, and I'm specifically substituting this type of name in, then I just fill that hole with the process P.
I see.
Yeah.
Yeah, interesting. Okay.
Yeah. Actually, I found there might be a really cool way for me to do these two rules. I think I can actually get rid of all this crap and just do something like otherwise.
Oh, yeah.
So if it's not this very specific thing here, then do this other thing. I think I'm not 100% sure. I haven't done that yet.
Yeah.
But cool. I saw that yesterday. I was looking through some functional language that they have defined in like a second part of the tutorial, and like they have some really cool stuff in the second part. So I'm going to start looking through all of that a little more.
Nice.
Yeah, and then I mean, this com rule is, essentially the same thing, right? Like if we have a receive listening on some name X and a send listening on that same name, and we also have to have this com catalyst present, then we just do that substitution, according to this rule, right? So like if it's, an evaluated name, well, then we do this special substitution, and in all other situations, it's just exactly replace, this quoted thing with for Y.
What are you calling special with eval? So why is this special?
Yeah, so they call this one, or at least this is what they call it in the regular row calc, is they call this one a semantic substitution. And basically, the thing is, we don't have so the semantic substitution for row calc is like when I have something like star y, and I want to substitute some quoted process in for y, then this is actually going to turn into just q by itself, right? Whereas if I were to do just regular substitution, this would be like star at q. And now the issue is if I don't have that, this then reduces to just q. Then so if I do have it, well, then there's no issue. I can just say just do the regular substitution and then have this additional rule basically. The problem is I thought I was going to be able to do that in this case, and it turns out that I couldn't do that in this case. So I'm trying to remember what the issue.
Are you doing substitution inside the context or not? You're just doing substitution as before, and you're not substituting anything inside the context, or.
What do you mean by substituting?
I mean, you're substituting only names and processes, right, and not something that is inside the context. Something inside the context. I mean, in this input-output constructors for context.
Yeah,
they're not holding variables, right? They only have holes.
Yeah, I mean, yeah, the hole is the variable for the context.
But not specifically, there is no name or the Boolean indices for these holes, right?
Well, not that I've implemented. I mean, so the name would just be the hole itself, basically. Yeah, there's only one name for the hole, though.
So when you're doing substitution, this is like an old regular substitution. And the context, inside the context, you're not doing anything, right? You're replacing something there.
Yeah, we're just taking every instance of the whole and replacing it with that process or whatever it is that we're substituting in.
Oh, so in a sense, you're inspecting context, right? Oh, no. Context can only have one hole, right? Not many holes.
Yeah, right.
Okay. That makes sense. Thanks. Wow, this is like a really very complicated stuff.
Yeah, it's hard to like go from thinking about row calc typically the way that I think about it, and then now trying to like implement these contexts, into the mix as well. Here, let's see. I have this is not at all what I was looking at, but let's see. I think it's in space time. Oh, come on. Oh, I'm not in the right folder, of course. All right. Can show some examples. Back in Java. So let's see. All right, so I have this example where basically, I'm gonna send some string on this name. And so this is why I wanted to allow identifiers for names, so I wouldn't have to like write out a context and everything every single time I wanted to send something on a name.
Sorry, this means that you're saying that this is the context only with the whole, and why you don't want to write it all the time, right?
Yeah, so I'm only going to use names like this just to like send send on this particular name, or use it as a variable in like a continuation basically, but only so that basically so that I don't have to write something like this every single time, you know, I want to do a send or a receive. I felt like it would just be easier for me to do that.
Okay.
But yeah,
can you write for X how this will look like? If you need to specify everything.
X
inside the these brackets, right?
So you're asking me, like, is there some direct translation of, like, you know?
No. I'm asking. You said, yeah, I don't want to write the whole context.
Yeah.
How this looks like if you need to write the whole.
Oh yeah. So if I had to, I could just you know, use something like that, or any process could go here, you know, nil or something. And then same thing here. You know, I would have to write some, you know, name like this.
But if you want to write a variable.
Yeah, right, exactly. So now if I want to write a variable, well, so that's the thing, is like in the calculus, the names are the variables. So I would even have to say, you know, something like, this is the variable that I'm listening for, and then I have this thing.
Oh, okay.
Yeah, and so it just gets horrible. So I really wanted to not do that.
Oh, I see.
So instead, yeah, so I have these variables there, but really, I mean, you know, technically I need to be writing something like a quoted process with a context. Yeah, it just gets so cumbersome.
This is basically the same problem of, like, it's way nicer to write like X bang nil as opposed to like at nil bang nil, or having to construct these bigger and bigger things to get unique channels.
Oh yeah, absolutely. Right. Yeah, and then the other thing that's confusing is, like, I mean, especially with you know, when it comes to ruling, it's like we have variables and we have these ground terms, and they're not the same thing in rolling. But technically in like row calc, they are kind of the same thing, because you only have names and processes. You have no notion of variables. It's like the names are the variables already. So yeah, so basically we got so the thing here is, right, like we have one send and these two listens are kind of competing to get that message. We have one com catalyst, and then we also have this location update, which has sort of like two things competing for it to update on. So what happened here? Well, I broke something apparently. I don't even know what that means. Well, maybe it'll just work from a previous compile. I don't feel like I've even changed anything, but you know, let's see what happens. So let's see. It's only going to give me one execution. So let me try to do. Let me see if I can look at some more possibilities that can come out of this. I know I compiled it with transition labels yesterday, so I want to see if it's still working. Yeah, okay, cool. So there were a couple race conditions going on in this, apparently a lot. I have a lot of final states here. So, all right, so this is all a little bit confusing. So basically, let's see what happened in this case. So in this case, it looks like this particular, I don't even know what to call this. This particular dropped name was not the winner in the location update. So it looks like this one was the winner in the location update. So what should have happened then is, so we should have a send on this channel, and it looks like we have a send on that channel. We should.
Sorry, I don't see your cursor.
Oh, you don't see the cursor. Oh, sorry. I don't know a good way to display any of this.
Highlight, man. Highlight.
Yeah, but then it's gonna, like, okay, well, either way. So so we have this location update. Yeah, I know, right? Then you lose the terminal window. Maybe whatever. It doesn't matter. So okay, so we should see either.
Okay, now I see a cursor.
Yeah.
Okay.
Oh, okay.
Okay.
So on this name, we should see we should see a message on this name. Either the message should be 2 or it should be 3 coming from the location update. So in this particular reduction, it looks like we have the 3 is the message on this one. And since 3 is the message on this one, we should see this context that was associated with 3 also as a COM catalyst that's available now. So let's see if that's the case. Yeah, so we have this a bang hole as one of the contexts that's available. And then, I mean, we also have some reductions going on from this as well, right? So we'll either have, well, I guess they'll reduce to the same thing either way, right? But point being is we should have one of these receives left over because only one is consumed by this send. And the context in which it's consumed it's going to be paired with 1, and then we'll put, whatever the message is, but the message is going to be the string A. So what we'll see is 2 different threads, one with a 1 and one with A, right? So this is from the 1 par in the context, and this is the actual process that we filled that hole with.
Oh, cool.
Let's see, is this the, oh, wow, wait a second, what just happened? I think I was looking at this one originally. All right. Oh, yeah, that's right. Okay, this is where we are. Yeah, either way, but like a 1 and an A from the context in the COM catalyst, and then this guy's just left over because it doesn't do anything. There's no other location update for it to reduce with. And that's basically it. And then we'll see, we had this received that's still left. So the one in which the variable was Y, I guess, but it doesn't really matter so much. And then we can go through some of these other ones, right? Like, so this one, same location update apparently happened because we still have this process laying around. But we have the other receive that was not consumed now.
So I feel like I made a ton of progress in terms of understanding like what this calculus does and how it reduces and stuff.
Yeah.
This is the part where Milner's tutorial had like examples of how you can encode stuff, and I feel like that's what I'm ready for.
Oh yeah, right. Like what extra can you encode now that we have these contexts?
Yeah.
Yeah, me too. And I don't know the answer to that question.
Yeah, right. Yeah, it seems like we're all in it together at this point.
Yeah, but it seems like synchrony constraint somehow, right? Like that's the whole point for introducing these contexts. So now the question is like, really, how do we get those synchrony constraints from these contexts?
Oh yeah.
Yeah.
And how this will be implemented in real rolling?
Oh yeah, like adding these contexts in like ad hoc. I'm not sure.
This is why I was thinking that this is already implemented, and we just need some.
Yeah. Well, I mean, it is. Maybe it's possible that. Well, no, I don't know. I was gonna say maybe it's possible that we could do something like all of the old syntax is still okay, but now we have these new names that have context, these COM catalysts. But I'm not sure how you make that coherent,
Or you take the old names and make, when you quote just a process, you make it syntactic sugar for that process in some specific probably the empty context. Yeah,
like just a hole or something. Yeah. I mean, that is definitely a way to do it. Yeah.
All right, guys, I got to jump out for today. This was fun.
Yeah, absolutely.
Yeah, this was great. Yeah.
Thanks a lot for teaching us so much. Yeah, I'm looking forward to next week.
Yeah. Thanks, Tomislav, for sharing your stuff.
Oh, no problem. Thanks you.
Yeah,
all right, see you later.
All right, take it easy.
See you. Bye.
Bye.